Okay, let's say we're given this information about sets A and B, that the number of elements in A is 5, the number of elements in B is 7, the number of elements in the universal set is 20, and the number in A intersection B is 2. Well, let's depict members of the sets just by little x's, okay? A has to have 5 things in it. A intersection B has to have 2. Anything in A intersection B is part of A. Right here is A intersection B. Well, it's got 2 elements in it. So to figure out how many elements to put here, well, we see that there have to be 5 elements in A. So we have 3 elements here. Okay, now how many elements in B? 7. So here's B. It includes the 2 that are in A intersection B. We have to have 7 elements in B, so we better have 5 more. Okay, so now there's 7 elements in B, there are 5 elements in A, and 2 elements in A intersection B. Now there are a total of 20 elements here in the whole universal set. So the rest of them have to go out here, okay, outside of A union B. Now the number in A union B is what? Well, we can count them. There's 3 and 2 is 5 and 5 more is 10. Let's do this a little more sophisticated way. That's the number in A plus the number in B. Of course, the number in A plus the number in B, 5 and 7 is 12. We know there are only 10, but we get that by saying, well, when we add the 5 elements in A to the 7 elements in B, we added these 2 elements in the intersection twice. So we better subtract the number in A intersection B. And that's going to be 5 plus 7 minus 2 equals 10. And that agrees with our picture. Now, this is always true. The number in A union B, you can add the number in A and add the number in B and understand that the number in the intersection of A and B was added each time. So it counted twice. So you better subtract the number in A intersection B, and now it's only been counted once. There is this part of it. Now, how about the number in U? Well, number in U is 20. How about the number in this last region here? We got 1, 2, 3, 4 regions. How many in this 4th region? Well, there are a total of 20 in here. And 10 of them are counted for A and B. So to get 20, we'd better add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's going to be the number in what? This set out here. Well, that set is everything outside of A union B. That's A union B prime. And we see that that is the number in U minus the number in A union B, which is 20 minus 10. 1, yeah, which is 10. Okay. This is always true. This is always true. Whoops, this. And this is particularly important when you're talking about 2 sets and how the numbers split between 2 sets. So, very important idea. If we, you see what we've done is we've got essentially 5, well, we've got 4 regions, 1, 2, 3, 4, that we can have numbers in, and they add up to the number in the universal set. So if I give you 4 numbers, okay, out of number in A, number in B, number in U, number in A intersection B and the number in A union B prime, okay, then you can always calculate the number in the other one. So okay, you got A, B, A intersection B, A union B, and U. If you know the number in 4 of those, you can find the number in the 5th. Okay, and there are, of course, other ways. For example, another example, we could let's say we knew that the number at A intersection B prime was 9. Number B intersection A prime is 12, let's say. Number in the universal set is, we'll say 30. And the number in A union B prime is, I got to be careful to give you a positive number. That can be just about anything. I'll just pick it up. Say 18. Okay. And forgive me, it's allergy season already. Even though it's cold out, not today so much. Okay, here's A and here's B. Now, where's A intersection B prime? Well, here's A. B prime's everything outside of B. Here's A intersection B prime. And that's just a single region here. And there are 9 in here. So we have 1, 2, 4, 5, 6, 7, 8, 9. And in B intersection A prime, we have 12. Well, B intersection A prime is this region, so better put in there. Okay, so already we have 21. Now, number has to be small enough. Okay, A union B quantity prime is this region out here. And there are 8 in this region. So how many have we got in here? We don't know how many in this region. Well, these regions are all disjoint. Now we could count them. There are a total of 19 here. 29, I'm sorry, 29 X's in there. If you got big numbers, you're not going to be able to write X's. You have to understand how these numbers relate. So those regions don't overlap. So if you add these numbers, there's nothing you're adding twice. Okay, they don't overlap, so running out of room here. So the number in the universal set, I have to aim this a little bit lower. So that kind of a watermark thing comes in your Zoom video. You don't want that in your way. Okay, number in U is number in A intersection B prime plus the number in B intersection A prime plus the cardinality of, I say number in, it's also the cardinality of. The cardinality is how many things you got in the set. Okay, that's going to be n of A union B prime. Into that we add the number in A intersection B, which is this region. So this is this region, this is this region, this is this region, and this is this region. They don't overlap. Now, since we know all these numbers except this one, we just write that out as an equation, and we can solve the number in A intersection B. It's going to be 1 because the number in U is 20. Number here is 9, and here's 12, and 9 and 12 makes 21. And here you have 8, which makes 29. So you have 20 equals total of 29 plus whatever's in here. What's in here better be 1. Okay, well, there are many ways you can reason these, and your text does this, but I want to make sure you're oriented to the problem, and then you just need to review it if you aren't able to solve problems of this nature. Review what you've done in the MyOpenMath. I'm sorry, the MyLab. Review the text sections. Do whatever's necessary to prepare yourself for the exam. Okay, let's consider an argument now. The argument is, if I'm big, then you're protected. If you're protected, there's the word there. I'm at peace. I'm at peace. Therefore, I'm big. Now, does that argument seem about right to you? It's not all that natural for people to be able to understand detailed logical arguments, complicated logical arguments. Now, this isn't all that complicated. If you're not used to thinking about logical arguments, you might find it a little confusing to understand whether this is a valid argument or not. Well, okay, so let's just take these statements. Okay, the first statement is, if I'm big, then you're protected. I'm going to tell you one of these pictures represents this statement. Either big is inside the protected circle or protected is inside the big circle. Which one is it? Or maybe could it be both? Well, if I put an X here, means you're protected. And I'm not big. So that's a possibility with these circles. Now out here, I'm just going to use P for protected. you're not protected, and I'm not big, if there's an X out here, and that's possible. Okay. If there's an X in here, then I'm big and you're protected. Okay. The only way this statement can be false is if I'm big and you're not protected. Okay. So does any one of these make the statement false? Well, here you're protected. That's true. I'm not big. Okay, that's false. Well, that's if false, then true. That's true. Anything can come from a false statement. Here, both statements are false. You're not protected. I'm not big. That doesn't contradict this. Okay. Now I can put an X here. So there are only three places an X can go: in here, in the part of this circle that's not in this circle, or outside. So here, I'm big and you're protected. Big is true, protected is true. So this embodies, if I'm big, you're protected. Here, it doesn't embody that. Okay, right here, mess that up, but you know what that word's going to be. That's a possibility. And that contradicts this. I'm big, that's true. You're protected, that's false. Okay. So we don't have to look any further. This one doesn't work. So this is the way it looks. If this, then this. So generally, if P then Q looks like this. P can't be true without Q being also true. You can't have P true, Q false. Okay, so we have this circle. Now the other one is, if you're protected, I'm at peace. So now we have I'm big, you're protected. And if you're protected, I'm at peace. And I shouldn't have used a P word here, but since I did. If you're protected, I'm at peace. This is the way it always looks. If this, then this. If this, then this. Okay. Now, the question is, if I'm at peace, does that mean that I'm big? Well, there are several places we could put X's. You put an X here, put an X out here, put an X here, put an X here. Any one of those could be an event that could happen. Okay. So here, this would stand for not big, not protected, not at peace. Here, at peace, not big, not protected. So according to this diagram, well, let's go on here. This mark stands for right, and it's pretty small. Okay, so let's focus in on that. Hopefully that's legible. Okay. And I'm not big, but you're protected and I'm at peace. Well, there are two events here. Where I'm big, you're protected. I'm sorry. This event, I'm not big. Okay. Even though this is the picture, we can't conclude that I'm big. This picture doesn't follow. Can't conclude it here either. So this is a picture of this part of the argument. This is the way being big, being protected, being at peace are related. You can't conclude that I'm big. It's possible, but this is also possible. Okay, so is this. So we can't conclude that I'm big. If we changed this to I'm not at peace, then the argument would hold. Okay, and you can think about how that would be drawn. If I'm not at peace, then I've got to be out here. And I can't be big. Okay. So if I'm not at peace, we can conclude that I'm not big. And that goes back. I'm going to do this in a different way too. If I'm not at peace, then since if you're protected, I'm at peace, it can't be true that you're protected. And let's go back here. Okay. If I'm not at peace, then we can't say that you're protected, because if you were, I'd be at peace. So you're not protected. Now, if you're not protected, well, if I'm big, then you are protected. If I'm not protected, then I'm not big. Goes back that way. And we can do the picture. It simply says, I'm not at peace. The only place I'm not at peace is outside of all this. And I'm certainly not in here. I'm not at peace, I'm not big. So this argument is invalid. With this, but if I take these two premises and do the I'm at peace, it's an invalid argument. On the other hand, if the next premise is I'm not at peace, then we can conclude that I'm not big. So this is invalid. This would be valid. You draw the circles and think about it. Think about how it works. Now there are rules of inference. Okay, I can write this as, I don't want to go into too much detail. I can write this as, if I'm big, you're protected. So it says, I'm big, then you're protected. If you're protected, I'm at peace. If you're protected, I'm at peace. And we call at peace being Q. So I'm big. We'll go ahead and use B. You're protected. That'll be big P. I'm at peace will be Q. And there we have the three premises that make up the argument, or three statements that make up the argument. Okay, so again, if I'm big, you're protected. If you're protected, I'm at peace. And I'm at peace. Therefore, big. That's one argument. Okay, that's this argument. The other would be okay, this is invalid. This is valid. Why is this valid? Because of modus tollens. And modus tollens says if P then Q and not Q tells you not P. So it's part of the argument tells you that P is false. Then you have if B then P, not P, therefore not B. And it's the argument I gave before. If I'm not at peace, then you can't be protected, because if you're protected, I am. So you're not protected. Well, that's what this is saying. And since you're not protected, if I was big, you would be, so I can't be big. That's what this is saying. Now, this is modus tollens in both cases. The structure of this is the same as the structure of this. I've just got a different letter here, a different letter for the conclusion. Okay, over here, this is invalid. This is the fallacy of the converse. Okay, I'm at peace. Now, if you're protected, then I'm at peace. Okay, but just because I'm at peace, that doesn't mean you're protected. That's the fallacy of the converse. Now, you have to read on that, and you have to look at the rules. Another way to structure this argument is if I'm big, you're protected. If you're protected, I'm at peace. So if I'm big, oh yeah, you're protected. If you're protected, I'm at peace. So if I'm big, I'm at peace. That's the first part of the argument. And then we combine that with not Q. And again by Otis Tollins, we get not P. Now, this is not a total survey of how you analyze arguments. This is an example of how you would justify an argument, and you're almost certainly going to have some arguments to analyze. You can analyze them with Venn diagrams. You can analyze them with these rules, and it's going to really help if you understand those rules and can make sense of them. So I'll take that for what it's worth. You know, I go on for hours and develop the whole topic, but I've got other things I have classes to prepare for tomorrow, and tests to post, and don't have time to do that. And you don't have time to watch hours and hours of video. I give you this much information, an idea of what it means to document and justify your solutions. Okay, so there we have it.